Hey guys, Coach Moss here. Welcome to Unit 4. We're going to start with graphing exponential and logarithmic equations. So this is our notes over those graphs and different features of them. So first things first, we're going to look at the exponential growth. If we were to look at y equals 2 to the power of x, if x were 0, it'd be 2 to the 0, which would just be 1. So our y-intercept is going to be 0, 1. And since it is exponential growth, it is going to be increasing. Let's look at 2 to the 1 would be 2. So I'm kind of just sketching a graph of it. 2 squared would be 4. 2 cubed would be 8. And as you see, it really just kind of starts to climb upwards. So I'm going to just sketch a little bit of what it looks like here. All right. Now, if we are looking at the negative side, if it were 2 to the negative 1, that would be 1/2. All right. And since if we are having negative x values, they're actually never going to produce negative y values because a negative exponent just becomes a fraction. So if it were 2 to the negative third, this would be 2 or 1 over 2 to the third. 2 to the negative 50th even would just be 1 over 2 to the 50th. So we would just be creating really, really, really tiny fractions, but it would never, our y value would never be 0. And this is why we have an asymptote at y equals 0. Our graph is never going to cross the x-axis into negative y values. All right, so our domain, if we are looking from left to right, is going to include all x values. So we're going to go from negative infinity to infinity because it will just continue to go. There's no x value that's not included, and even though we can't see it, it's still going to just keep going upwards as the x values get larger. If we're talking about range, just as I said before, it will never cross or touch the y-axis, or I'm sorry, the x-axis, and it will continue to go upwards. So we're going to have 0 to infinity on the range. And then end behavior, our end behavior. So the limit of f of x as x approaches infinity, this one's going to be very simple. It's going to keep going upwards, so that's going to give us infinity. So then the limit of f of x as x approaches negative infinity will be 0 for us. All right, so this is going to be just the basics of our exponential. Now let's look at our decay. Decay means we're going to see decrease from left to right, and we're using 1/2 to the x power. Now, again, any exponent that is 0 is going to produce, anything to the power of 0 is going to produce a 1. 1/2 to the 0 power, 100 to the 0 power, it's always going to be 1. So our y-intercept is still going to be the same. It's going to be 0, 1. Now, if we were to use 1/2 to the first power, as if x were 1, that would just produce 1/2. So this one's going to look basically the opposite of our exponential growth. As our exponents gets larger, our fraction is going to get smaller and smaller because as we multiply fractions by themselves, 1/2, then 1/4, then 1/8, and it's just going to get tinier and tinier, but it, again, will never touch the x-axis. But if we were to take 1/2 and put it to, let's say, the negative 4th power, this becomes 1 over, 1/2 to the 4th power, and that will end up flipping the fraction into a whole number. Because this would technically be 1 divided by, let's see, 2 times 1/8. And then we would flip that fraction and multiply, which would actually produce 8. So when it's negative 4, our x value is actually 8. So as we get into negative x values, our y values are going upwards. And this is why this one decreases from left to right. It is decaying as we go across, and then our exponential growth is increasing. So our domain, again, is going to be negative infinity to infinity, because we're going to include all x values. As far as range goes, it's going to be very similar again. We're not going to touch the x-axis, so we will go from 0 up into infinity. The asymptote is still the same at y equals 0, so we're never going to touch it. And then end behavior. The limit of f of x. As x approaches infinity, now as we go across towards infinity, we're getting closer to 0. And then the limit of f of x as x approaches negative infinity is going to give us a positive infinity y value. So it's very, very similar. They're the same in several respects. Domain, range, the asymptote, the y-intercept. The only thing that is different between these two graphs is the end behavior. So we have a tiny little question here. What would the graph of look like? And it's supposed to be y equals 2 to the negative x. So when our x value is flipped negative, that means we flip over the y-axis. And if you think about it, 2 to the negative x is the same as 1 over 2 to the x, which is exactly our exponential decay. So it would create the graph of our exponential decay. All right, let's look at natural base exponential functions. This one's going to be very similar to the graph that we have up here, because we know that e is approximately 2.7. That's going to be very similar to what we have up here, since we used 2 as our base to the x power, and then we have e to the x. All right, so if r is greater than 0, which is our value attached to the x, that means we have a positive x value, then it's going to be a growth. And then if r is less than 0, which means it's negative, it would create an e to the negative x. That would cause our decay. So I'm not going to regraph these, but this would cause a decay graph, just as we have above. We've just created it right here. And then this would cause a growth. Because as I've put here, this would be e to the x, because we're saying that our r is positive. Whatever value is attached to x is positive. And then over here, whatever value is attached to x is negative, which would cause the decay. All right, so I'm going to just shorten that a little bit and move on to the next part. So let's look at a logarithmic function. I'm not going to spend too much time on this one as well, because of how much we've already gone over. We've already done the exponential function, but I am going to show you how they differ from each other in that way. So if we're talking about the logarithmic function of x, if I were to graph it, I'm going to graph it for you. Log. All right, it's going to look like this graph here. It looks like we have it crosses the x-axis at 1, 0. So we actually have no y-intercept here. It actually is never technically going to cross the y-axis. It looks like it touches and it gets very, very, very close, but as we go, it'll never go across it. All right, so the only intercept we have is going to be an x on this graph, and that is going to be 1, 0. All right, I'm going to sketch it just a little bit based off of this picture. It's not going to be exact, but it's going to look very similar to what we've already done. I'm just going through the bases so we can answer these questions here. So the asymptote for this one is actually going to be at x equals 0, because it will never cross the vertical x, which is going to be x equals 0. Domain. So our domain is going to be what x values do we see it touching or crossing? It is never going to hit any of these negatives. It's never going to cross 0. So our domain is just from 0 to infinity because it'll never touch this left side of the graph. Now our range will be negative infinity to positive infinity. It can touch every value of the y-axis. And then in behavior,